Sets are a collection we can use for quickly checking if a value exists. A set can never contain multiple copies of the same value. Maps and sets are different, but when you look behind the scenes, a set is similar to a map, except a set is only going to have keys and not a key pair value like a map. So, like maps though, there are two sets Rust give us, a hash set and a B-tree set. And again, hash set and B-tree set are similar, so I'm only going to show you how we can use a hash set. So let's start out by adding the hash set into our scope. And now we can come down here and we can create a mutable hash set with the new keyword. And like a hash map, we can have length to return how many values are in our hash set, as well as is empty to return a Boolean on if our set is empty or not. So, just like a hash map, let's begin adding in some values with the insert keyword. And we'll add in our values. And in this case, we'll just add in 1, 2, 3, and 4. And 4. So to print this out, we can use what's known as an iterator. And we'll be able to talk a little bit more about iterators a little bit later in this course. But we can do for x in hs.iter. Now we just want to print line iter and x. So now if we run this, we'll see our iterator, and I'm going to get rid of this in because that'll bother me. But we have 1, 2, 3, and 4, which is what we added in. So that's awesome. To remove a value like we did in a vector, we can just say, hey, we want to remove a reference to the 2, and then up here we'll actually cut and paste this, run it again, and now we only have 1, 3, and 4. But I'm going to comment that out just to keep our values in there. So now I'm going to create another hash set called hs2, just for hash set 2, and have it be new. And then I'm going to come down here, up here, and let's say 1, 3, 5, 1, 3, 5, and 7. And then obviously we need to change these to hash set 2. So now we have another hash set with the values 1, 3, and 5 in it. So now with sets, we are actually given some new methods. So, and the first one we're going to talk about is intersection. And when you check intersection within two sets, you're going to see which values are in both sets. So the first way we can do this is say for x in hash set dot intersection, and then pass in a reference to the second hash set, and now we can print line, and we're going to say intersection x. And so we see we have 1 and 3 in both sets, and intersection has printed out 1 and 3 between the two sets. So another way that we can do this, a more shorthand way, is we can actually say let intersection equal to a reference to the first set, the binary bitwise AND operator, so the ampersand sign, and then a reference to the second set. So now intersection is going to be a set that's going to contain the values that are in both sets. So let's print that out. For x in intersection, print line, and then we're going to say shorthand way, and now x. And we expect this to still be the same results of 1 and 3, which is what we got. So this is a shorthand way, shorthand intersection, using the bitwise, the binary bitwise and percent operator. Another one that we have is union. And union is going to return values that are in either the first hash set or the second hash set. So I'm only going to show you the shorthand way because otherwise it's going to be the same way above. Instead of it being hash set, then method called intersection, our method call would be union. So let's do our shorthand way and say a reference to the hash set with the binary OR operator and then hash set 2. So now union is going to be a set that's going to contain values that are in either of the two hash sets. So let's print this out to make sure that we got the correct values. Union and then x, and for union in, there we go. And now if we run this, we have union 1, 2, 3, 4, 5, and 7. So we can see that we didn't have duplicate values of 1 or 3, but we have all the values occurring once between the two sets. And then lastly, we can do the difference. So likewise, difference would be called like this, but we're going to do the shorthand way and say let diff equals a reference to the first hash set minus, so the difference between the second hash set. And now we can print this out and see what the difference is. And we'll say diff and x. And so with the difference, we want to see what values are in the first hash set, but not the second hash set. So if we run this, we see that we have 2 and 4. And that would be correct because we have 2, 4, and then in the second hash set, we do not have 2 and 4. So there are more methods we can use on a set, but these are some of the main ones. And as you can see, we can do a lot of logic handling very quickly on sets. Again, these are just some of the collections we have available to us in Rust. So feel free to check out more collections. But again, later on down the road, I do plan to show how we can create some of the data structures available to use in Rust so that we can continue to learn and become more proficient in our Rust journey.